Okay, good day, guys. Okay, let's continue the part two of quantities and measurements we started earlier on. So we are looking at we see that the three basic or the most important fundamental quantities are mass, length, and time. And in part one, we just finished about what we did quantities and measurement of mass. So let's talk about length. So if you come to length, length can be measured with three instruments or equipment. So the first one is meter rule. Then the second one is vernier caliper. Then the third one is micro screw gauge. So these are the three instruments we use to measure mass. Sorry, we use to measure length. So meter rule, so vernier caliper and microscope. So this is used to measure like bigger length. Basically, you can just say that this is used to measure bigger length, smaller length, and smallest length. Do you understand? So it's just like in their decreasing order from the highest, let's say the highest length to the least length. Okay, so what do you have to know about meter rule? First of all, what you have to know about all of them, something that we established when we are talking about mass, is what you need to know about their reading accuracies. So measuring accuracy, and we say the measuring accuracy is also called that is smallest graduation. So what is the reading accuracy, smallest graduation of meter rule? 1 millimeter or 0.1 cm. And this one is 0.1 millimeter or 0.01 cm. Then this one is 0.01 millimeter or 0.001 cm. This is just like you are increasing, you understand? Okay, then if you remember when we talked about the estimated uncertainty or least possible error. It's just half of what the measuring accuracy. So this one will not be one over what that is divide all of them by half. That is half of it. Divide by two, divide by two, divide by two. Divide. So this is if you divide all of them by two is now their what least possible error or what estimated what uncertainty. Then the next thing I want you to know is if you come to let's finish meter rule. So what do you have to know? You use to measure bigger lengths, like is the length of field, that is a football field or something like that. Then what else do you have to know? The reading accuracy. This is the 1 millimeter or 0.1 cm. Then the next question will be what is the is estimated uncertainty or what least possible error? Just half of that is 0.5 for this one, then 0.05 cm for this one. Then they have jam. Sometimes you might know it like this, and jam will come and present the question as the reading accuracy of meter rule is just if the answers are in millimeter, go to the one that doesn't have points in it because this is just like normal units. But if the answers are in cm, then you let's say for example now it's now 23. You choose the one that have just one decimal place. This is 23.0 cm. Is it the one 23.00? It will be it depends on whether it's vena caliper or microscope. But I don't know if you understand the point I'm making. But the point I'm making here is if you look at meter rule, just in the millimeter side is to the nearest whole number. Then this one is a one decimal place. Just look for the option that have one decimal place. That is the answer. Then the next thing they'll ask you in this meter rule is what is the what the the precaution to take while using this meter rule. The precaution is a jump question. They say that the precaution is you look vertically downwards on the meter rule. If you want to avoid error due to parallels, you look vertically downwards on the meter rule like this, vertically downwards like this, not slantily. So you don't look slantily, but what vertically downwards. I think we are done with this guy. Then for vena caliper, you have already noted. We will, first of all, we'll say that this one is more accurate than the meter rule and it measures smaller length. So what can you use vernier caliper to measure? This is the jam question. So there are just three. I call them TID. T means thickness of meter rule. Then I is internal and external diameter. Internal and external diameter of a tube. Tube here can be, let's say, test tube or something like that. Then the next thing you have to know is D is a, which is a thickness, that sorry, diameter of a diameter of a rod. So that is the three things we use vernier caliper to measure. Then the next thing you have to know about vernier caliper is it has two scales. It has two scales. It has two scales. You have main scale and what? Vernier scale. Then if you come about the next thing you have to know about this vernier caliper again is the precaution while using this vernier caliper. The precaution is that you avoid any zero error. And how do you avoid any zero error? By ensuring that by setting the zeros of main scale and vernier scale to coincide. Coincide means like where they meet. Because most times, if you are talking about the reading of a vernier caliper, you first of all get the main scale. Then, if you come to the vernier scale, you now come where the vernier scale and the main scale coincide. Then you add the two numbers. That is how to look for what is that is readings of what vernier caliper. Then for micro screw gauge, you have already noted that it is more accurate than this, and it measures this is reading accuracy. You already know the ease of method and setting to least possible error, dividing half of this. Then the next thing is that what can we use this guy to measure? It's still the same thing, three things. You know, this one is TID, this one is now TDD. The T here is, instead of thickness of meter rule, we say thickness of piece of paper. Thickness of piece of paper. Then D is internal and external diameter of a tube. Then this one is now diameter of a small ball. Of a small ball. Example is, let's say, simple pendulum. Do you understand? That is example of small ball, simple pendulum. Then D is diameter of wire. Diameter of a wire. No, this one is diameter of a rod. This one is diameter of a wire. Then also, micro screw gauge as vernier caliper has main scale and vernier scale. So the same way, you take the reading of main scale, then you go to where the main scale and the vernier scale coincide. That is how to take the reading of what? This guy. Then the next thing here you have to note is the precaution while using this instrument. The precaution, still the same thing. You avoid zero error. How do you avoid zero error? There's something called anvil. There's anvil and spindle in this microscope. Make sure that the anvil and the spindle are both closed. So that is the precaution in this guy. I think we are done with length. Yes, I think we are done with length. Maybe any question you can drop it in the comment section. Then the last but not the least is the time. Time. So time, first of all, what is the reading accuracy? Okay, time is measured by instruments, stopwatch. Some people can say stop clock or stopwatch, but let's stopwatch. Then the next thing I want you to know, we have the reading accuracy of stopwatch is 0.1 second. Then the next thing here is um, time. That is, we have two most accurate watch or clock. Like they are more accurate than this stopwatch. They are more accurate than this stopwatch. They are the two. We have an atomic clock and a quartz crystal clock. So this clock, they measure time more accurate than what stopwatch. But the common one we use in our area is what? Is what? Stop watch. So it means that the reading accuracy is 0.1 or least or what? Sorry, smallest graduation. Then it now means that the least possible error is now half of 0.1. Okay, I think we are done with time. Then you have to just note these points. Okay, like now, for example, if you want to take a measure a volume, take a volume of an irregular substance, like let's say stone. It works on the principle of Archimedes. The one we do upthrust and the density and upthrust, you understand it. But how to measure the volume of irregular object is that you put that irregular object first of all in the liquid that is not soluble in. Then the volume of the liquid that that object displaced is equal to the weight or the volume of that object. So that is what Archimedes is talking about. That when a body is totally or partially immersed in a fluid or in liquid, that it displaces, it experiences an upthrust, which is equal to the weight of that object, or whether it is equal to the volume of the object displaced. So then you already know volume of liquid in chemistry is measured using either pipette or measuring cylinder or burette. Okay, I think these are all we have to know about measurements and what quantities. The next topic we are going to look at is what dimension. We'll see you guys in the next class. Bye.